Imagine this: Mars, our mysterious neighbor, suddenly becomes more than just a desolate, barren wasteland in the depths of space. What if it had once harbored life? This idea has captivated the imaginations of astronomers, scientists, and dreamers for decades. The question of whether we are alone in the universe has kept humanity on its toes, looking to the skies with a mix of wonder, curiosity, and hope. And now, a breakthrough discovery by NASA's Perseverance rover is adding fuel to the fire. Could Mars have supported life in its distant past? And if so, could evidence of that life still be hiding beneath the surface? NASA's Perseverance rover, which has been exploring the surface of Mars since February 18, 2021, is shedding new light on this possibility. Recently, the rover discovered something extraordinary: a mysterious rock formation in the Jezero Crater that suggests Mars could have been a habitat for microbial life. This rock, which has been named Chava Falls, contains unusual patterns and chemical signatures that closely resemble marks created by microorganisms on Earth. But what does this discovery really mean? Is it possible that Mars was home to life in its distant past? And if so, could there be any remnants of that life still existing today, hidden beneath the Martian surface? The idea that life could have existed on Mars is not new. Scientists have long suspected that, in Mars' distant past, conditions might have been favorable for life. Evidence suggests that billions of years ago, Mars had a much warmer and wetter environment. In fact, scientists believe that the Jezero Crater was once home to a large lake fed by rivers, making it one of the most promising locations on the planet for studying ancient Martian history. And now, with this new discovery, we may be closer than ever to answering one of the most profound questions in science: did life ever exist on Mars? The Chava Falls rock formation, found in the Jezero Crater, is unlike anything scientists have seen before. The rock is about 1 meter long and 60 centimeters wide, and it is covered in peculiar spots that contain iron and phosphorus, two elements that are essential to life as we know it. These spots, which are only a few millimeters in size, are surrounded by dark rings made of materials that have been identified as iron oxide, or hematite. Hematite is common on Mars, but what sets these spots apart is their chemical composition. In addition to iron, they contain phosphate and organic carbon compounds, elements that are strongly associated with life on Earth. Could these spots be the remnants of ancient Martian microorganisms, or is there another explanation for their presence? The discovery of organic carbon on Mars is a significant breakthrough, but it's not the final answer. While organic molecules can be formed through non-biological processes, such as volcanic activity, the combination of elements found in these spots is strikingly similar to what we see in microbial environments on Earth. Here on our planet, microorganisms often use iron and phosphorus as energy sources, leaving behind traces of their existence in the form of organic compounds. Could it be that similar microbial life once existed on Mars, and left behind these chemical signatures as evidence of its presence? While it's still too early to say for sure, this discovery raises exciting possibilities. What makes this finding even more significant is the context in which it was made. Mars, in its distant past, had a much different environment than the cold, dry desert we see today. Evidence suggests that Mars had rivers, lakes, and possibly even an ocean, environments that could have supported life. The Jezero Crater, where Chava Falls was found, was once home to a vast lake, which would have provided the perfect conditions for microbial life to thrive. This discovery suggests that Mars was once a planet teeming with life, or at least had the potential to be. But where did all the water go? Mars, today, is a dry, barren world. Its surface is covered in dust and rock, and liquid water no longer flows across the landscape. Scientists have long wondered what happened to the water that once covered the planet. Did it evaporate into space, or did it seep underground? Recent research has revealed that much of the water on Mars didn't disappear, but instead sank deep into the planet's crust, hidden beneath layers of rock and dust. In fact, seismic data gathered by NASA's InSight mission suggests that there could be vast reservoirs of liquid water buried beneath the Martian surface, deep within the planet's crust. This discovery has major implications for the search for life on Mars. If water is still present beneath the surface, could it be that microbial life is hiding there as well? Researchers are now focused on studying the Martian subsurface, looking for signs of life that may be buried beneath the surface. This research is still in its early stages, but the possibility that life could still exist on Mars, even today, is one of the most exciting prospects in space exploration. To understand the significance of the Chava Falls discovery, it's important to understand the history of water on Mars. Mars, billions of years ago, was a much warmer and wetter planet. It had a thick atmosphere that allowed liquid water to flow freely across its surface. However, over time, the Martian climate began to change. The planet's atmosphere became thin, and the surface became cold and dry. The once abundant water on Mars either evaporated into space or seeped underground, leaving behind only traces of its former presence. This dramatic climate shift is thought to have made the surface of Mars inhospitable to life. But did the conditions below the surface remain suitable for life to survive? Could microbial organisms have found shelter in underground water reserves, where they could continue to exist in relative safety? These questions are at the heart of the ongoing search for life on Mars. The Perseverance rover, which has been exploring the surface of Mars for nearly 3 years, is at the forefront of this search. Equipped with an array of scientific instruments, the rover is gathering data on the Martian environment and collecting rock samples that will eventually be returned to Earth for further analysis. In addition to studying the chemical composition of rocks and soil, Perseverance is also looking for signs of ancient life. The rover is specifically studying the Jezero Crater, which was once home to a large lake. By analyzing the rocks and sediment in this area, scientists hope to uncover clues about Mars' past and determine whether life ever existed on the planet. One of the most promising aspects of this research is the discovery of sulfate minerals in the Jezero Crater. Sulfates are minerals that form in the presence of water, and their presence suggests that the region was once much wetter than it is today. In addition to sulfates, the Perseverance rover has also detected iron-rich minerals, which are often associated with the presence of water. These findings point to the possibility that Mars, in the distant past, had a much more hospitable environment, one that could have supported microbial life. But what about the volcanic activity on Mars? Volcanic eruptions could have played a role in shaping the planet's surface and its atmosphere. Volcanic activity can also release organic compounds into the environment, which could explain some of the chemical signatures found in the Chava Falls rock formation. However, while volcanic activity could potentially explain some of the organic material on Mars, it's not the only possibility. Researchers are also considering the role that microbial life might have played in creating these organic compounds. After all, on Earth, microorganisms are responsible for producing a wide range of organic molecules, many of which are essential to life. The presence of olivine, a mineral commonly found in volcanic environments, in the Chava Falls rock formation adds another layer of complexity to the mystery. Olivine is a key component of magma, and its presence suggests that Mars may have experienced volcanic activity in the past. However, this doesn't necessarily rule out the possibility that the organic compounds found in the rock could be the result of microbial activity. The presence of both volcanic minerals and organic compounds in the same location raises important questions about the history of Mars and its potential to support life. As scientists continue to study the data sent back by Perseverance, they are also planning future missions to Mars. One of the most exciting developments is the Mars Sample Return mission, which will bring samples from Mars back to Earth for analysis. This mission will allow scientists to study the Martian rocks and soil in much greater detail, using advanced laboratory techniques to determine whether they contain evidence of ancient life. It will also help researchers understand the history of water on Mars and how it may have influenced the planet's ability to support life. In the meantime, seismic data gathered by the Mars InSight mission is providing valuable insights into the Martian subsurface. InSight seismometers have detected tremors, or Marsquakes, that suggest there may be large underground water reservoirs beneath the planet's surface. These findings have sparked renewed interest in the potential for life on Mars. If there is liquid water deep beneath the surface, could it be that microbial life is hiding in these hidden underground lakes? The idea of underground Martian life has captivated scientists, and the prospect of finding living organisms on Mars, whether in the past or present, is one of the most exciting possibilities in space exploration. The discovery of a vast underground water reservoir on Mars could also help explain some of the mysteries surrounding the planet's climate. It's long been a puzzle as to where all the water on Mars went. While some scientists have suggested that the water evaporated into space, others believe that much of it seeped underground. The discovery of water in the Martian subsurface could provide the missing piece of the puzzle, offering new clues about the planet's past climate and its potential to support life. As we continue to explore Mars and gather more data, we are learning more about the planet's history and its potential to harbor life. The discovery of organic compounds in the Chava Falls rock formation is just the beginning of what promises to be a thrilling journey of discovery. If Mars once supported life, it could mean that life is more common in the universe than we ever imagined. Perhaps Mars is not an isolated case, but rather one of many planets that may have harbored life at some point in their history. The search for life on Mars is not just a search for answers to our own existence, it is a quest to understand the broader implications of life in the universe. In conclusion, the discovery of Chava Falls and the organic compounds found within it is a game-changer in the search for life on Mars. While we are still far from definitive proof that life ever existed on the red planet, this discovery opens the door to new possibilities. Mars, once thought to be a sterile, lifeless world, may have been a thriving habitat for microbial life billions of years ago. And who knows? Perhaps there are still secrets hidden beneath the Martian surface, waiting to be uncovered. The journey to uncover the mysteries of Mars is just beginning, and it promises to reveal a new chapter in our understanding of life in the universe.